In my previous video, I covered how to set up port isolation using UniFi switches. That topic naturally leads to today's video, which is about private VLAN in UniFi world. By nature, a VLAN in fact is just a broadcast domain. It is working in layer 2. Private VLAN furtherly partition a VLAN into subdomains so that you can isolate ports from each other. Let me use this diagram to introduce several important concepts for private VLANs. This diagram is a little bit busy, bear with me. The big blue outline is for a primary VLAN. A private VLAN domain only has one primary VLAN. Each port within this private VLAN domain is a member of this primary VLAN, and there are also secondary VLANs, so they provide isolations between the ports. There are two types of secondary VLAN: community VLAN or isolated VLAN. We will discuss the concepts in more details later, but just from this diagram you can briefly know already the ports within a community VLAN, they can communicate with each other, but for isolated VLAN they cannot. Among different secondary VLANs, they cannot communicate with each other even if they are both community VLAN. And from the blue and the green arrows, you can see the way how they communicate with outside through the promiscuous part. Basically, the promiscuous part will communicate with all the secondary VLANs through the primary VLAN, and those secondary VLANs will communicate back through the promiscuous part with their corresponding secondary VLAN. That's why you see different color of arrows, and you will see how it works when we go to the system. And when it comes to ports, there are three different ports listed here. This one is called promiscuous port. All the communications from the secondary VLANs, they are through this port, and within each secondary VLAN there are different ports, either community port or isolated port, based on your requirement regarding whether you want them to communicate with each other or not. I am going to use this type of lab environment to show you how the private VLANs work in UniFi switches. I'm going to use a Pro switch, port 24. I will connect it to my lab's router, and this part will be the promiscuous part. I have 3 secondary VLANs set up, 2 community VLANs, just 1 isolated VLAN, and within each secondary VLAN I have 2 ports, and each port is connected using a Linux virtual machine. So in total I have 6 Linux virtual machines connected to 6 physical ports, and I have another port which is port 23. I connected with a separate Linux just to show, okay, if you don't add a port to your private VLAN, what will happen, whether it can participate in the communications. Yeah, this is the simple environment. Let's directly jump to the system. This is the screen layout I'm going to use for this video. I have 9 windows open. 7 of them are for the Linux virtual machines. Top right one is for the server shown on the screen here. The other 6, they are the clients from 1 to 6. In this UniFi network controller window, I have USW Pro 24's ports layout here. For 6 of the ports, they are connected to the 6 Linux virtual machine, and the port 23 is to the server, and the very last one, port 24, is connected to the router. One thing I want to mention is private VLAN function is not supported in the UI, in the front-end network controller. If you want to configure anything about that, you have to do it in backend using CLI. That's why I'm going to launch a SSH session into the switch, then we can start configuration. Another thing I need to mention is you cannot configure the default VLAN, VLAN 1, as a private VLAN. I have to configure this port 24, which is connected to the router. I'm going to use VLAN 8 to configure a private VLAN, and I configured port 24 with that particular port profile so that all the Linux virtual machines will get the VLAN 8 IP address. Let me show the IP addresses for the 7 virtual machines, starting from client 1. Yeah, as you can see, it's subnet 8. That's for the VLAN 8 I already configured. And similarly, I will do the same thing for the other VLANs. Okay, all 7 of them, they have the IP addresses in the same subnet. Before I start configuring anything, by default, they should be able to connect to internet. They should be able to connect to each other. Let's validate it. From client 1, I want to ping client 2. Yeah, it's pingable. From client 2, ping client 1. No problem. And then from client 1, ping internet. No problem. And from client 2, ping internet. Okay, so similarly, I will do the same thing for the pairs of 3 and 4 and 5 and 6. I won't waste your time. I will directly do it. Okay, I've done for the other 4 Linux virtual machines, and then move on to the final one, the server one. So from server, let me just pick a random client machine. So let's say client 1. Let me ping client 1 from the server. Okay, and then similarly ping internet here. Okay, so no problem at all for all the 7 Linux virtual machines, right? Now let's go to SSH to start the configuration. I'm going to use this terminal window to SSH into the UniFi switch. Okay, I mean, the way to go to CLI, telnet to itself. EN for enable. We need to first add the secondary private VLANs. Go to VLAN database. First show VLAN. Okay, now we have 1 and 8, right? As we mentioned, just to make sure the Linux virtual machines to get IP address and we can start configuring private VLAN, I already added a new VLAN 8 in the UniFi controller. So that's why we have 1 and 8 here. And let's add the other 3 for the secondary VLANs. I want to say VLAN 81 to 83. Okay, done. Add a routing, VLAN routing 8, 1, then exit. Okay, so now let's go to config mode. And we want to first configure VLAN 8. If we check the diagram for VLAN 8, we want it to be the primary private VLAN, and then primary. Okay. So now VLAN 8 is the primary private VLAN. Then we want to associate the other community VLANs or isolate VLANs to the primary VLAN. The way to do that is use this command, private VLAN association. And then I want to say 81 to 83, which we just created. Okay, exit. And now let's move on to these 2 green secondary VLANs. They are community VLANs. I want to configure 81 and 83. I want to define them as private VLAN community. Okay, done. Let's move on to the red one, which is the isolated VLAN. We want to use VLAN number 82. Let me go to VLAN 82. Then say private VLAN isolated. Okay, we are done with the settings for the 3 secondary VLANs. Now we need to move on to the port definition, because we need to let the system know which port is for which secondary VLAN or which port is the promiscuous port. We need to use the interface command. Let me start with the 24 port, which is the very important promiscuous port. I say port 24. Then the command is switch port mode private VLAN promiscuous. And then we want to let it know how to map the primary VLAN IDs. So we say switch port private VLAN mapping. So see, now we already encountered the first problem. No matter what I type here, there's no response. Basically, that means the connection is already broken between my SSH client and the switch. Why? See what we just executed? We designate the port 24 as the promiscuous port. Right after that's in effect, the switch itself won't be able to communicate through this uplink and to get the normal, let's say, DHCP or similar network traffic anymore. Now let me go to my server room, take a picture of the monitor screen of the switch. We can confirm that's the case. This is the LCD screen for the switch. As you can see, the IP address is .1.20, the familiar default IP address if DHCP doesn't work. Now, if we go back to the original screen layout, let's see all the ping session status. As you can see, when the virtual machines ping each other, no impact. All the pings are still going on, no errors, but all the internet traffics, they are unable to proceed. They cannot reach the internet. Why is that? So remember, the only port we started configure is the port 24, which is the promiscuous port, which means once I add this port as promiscuous port, it will only pass the private VLAN related traffics, but we haven't added any other ports to the private VLAN yet. All the other ports, they are not isolated at all, so that's why they are able to communicate with each other, but they cannot reach the internet because their traffic won't be passed through the promiscuous port. But basically, that's the same reason why we lost connection to the switch in the SS session. The way to proceed is we can simply use this Linux virtual machine and manually change the IP address to the subnet 1 to be the same as the default UniFi switch IP address, so that at least the server Linux version can connect to the switch, so I can proceed with the SSH. Let's do it now. So this is the Linux virtual machine for server. Let me go to the network setting. Then in IPv4, let me say menu and give it a IP address. Let me say 111 and subnet and gateway, doesn't matter. Let's see what's the IP address now. Okay, now it's effective. Let me SSH again. Yeah, we are in. So let me use the same way, continue the interface configuration. Telnet to itself, en for enable, config mode, continue with the interface configuration for port 24. Let's rerun the command which failed due to the connection issue. Switch port, private VLAN, mapping, and we want to map 8 and 81 to 83. So now the promiscuous port is configured for port 24. Let's move on to port 1 and 5. According to the slide, port 1 and 5 is for these two Linux clients, and they are supposed to be part of the secondary community VLAN. Let's start configuring it. Switch to interface 1 and 5. Okay, and run the same command, switch port. This time we want to designate them to host port mode. They are not promiscuous port, they are simply host ports. The same command, and then we want to associate the host ports to VLAN 8 and 81. 8 is the primary VLAN, 81 is the first green secondary VLAN, which is a community VLAN. So that's why here we say host association 8 and 81. Done with the port 1 and 5. This time, let's check the current ping session status. Let's first check client 1 and 2. See, now they are able to connect to internet. And see the other 4 Linux virtual machines, the internet pings, they still fail. But why 1 and 2, why they are able to do that? Because we added these 2 ports as the host ports. Now they are part of the primary private VLAN. Their communication can be done through the promiscuous ports. That's why their internet works now, right? And then let's see, they are able to ping each other. Why they are able to do that? because they are part of the same community VLAN. Community VLAN means the ports within it, they can communicate with each other. So then the first green one, this first secondary community VLAN, it works as expected. Then let's move on to the red one, which is the isolated secondary VLAN. Before we change the configuration for 3 and 4, see, they are still able to communicate with each other and they are unable to connect to internet. Let's say after the configuration, what's the status change? Move on to interface 9 and 13 for the isolated VLAN. Interface 9 and 13. This time, we want to run switch port command. The mode, again, they are host ports for sure, but this time we want to associate them with a different secondary VLAN, which is 882. So not 81. Remember, see the command before that, we associate port 1 file to 81, right? But for port 9 and 13, we want to associate with 82, which is the isolated VLAN. Now they are supposed to be working already. Let's check in the system. Yeah, see, first you see the internet ping, they are working, right? And then see when they ping each other, both pings failed. They are unable to ping each other anymore. Before we add them as the part of the isolated VLAN, they are able to communicate, right? But now they are unable. Why? Because that's the purpose of the so-called isolated VLAN, because we do not want the ports within this secondary VLAN to communicate with each other. That's why they cannot, but they can still communicate to outside world, to internet, through the promiscuous port. So we just validated this scenario for isolated VLAN. Now let's move on to the second community VLAN for port 17 and 21. Interface 17 and 21. And this time is similar to the very first ports. We want to configure them as, of course, host ports. Associate them with VLAN 8 for sure, and this time 83. 83 is for this second green community VLAN. That's why here we say 83. Okay, see, they are able to connect to internet now, and they are still able to communicate with each other. That's the whole point of community private VLAN, right? So it works as expected. Another thing I want to validate is whether you can communicate from this first community VLAN to the second community VLAN. Even though they are both community VLAN, but they belong to different community VLANs. Let's see whether they are able to communicate with each other. Then let me launch another ping session. Just use this one as example. And let me ping maybe port 5 here. Port 5 has address .8.185. Let me do it. 185. No, it cannot. Let me move the slide to the first one. Remember we mentioned, see this red arrow between these two community VLANs, they are unable to communicate even though they are both community VLAN, right? Perfect. That's exactly what we expect. So now we are good with the 3 example secondary VLANs. But remember, we have another machine for server, right? And we haven't touched port 23, which means it's not part of this primary private VLAN, which means it's not supposed to be able to connect to internet because the traffic cannot pass the promiscuous port. But let's validate it. See, this is the server's window. For the internet part, you can see if I ping the internet IP address, the ping will fail. It says network is unreachable because it's not part of the private VLAN. But let's see the other side. When we ping the client 1 in this window, you can see the session is frozen. There's no progress. It's simply failing now. But just to double check, let's run it again. So see the same error. In fact, the symptom simply means the machine doesn't have IP address. Because we haven't touched port 23, the server Linux version simply cannot connect to those ports which are part of the private VLAN. All the traffic need to go through the promiscuous port. Okay, I know sometimes it's a little bit confusing and we are talking about so many ports, so many different private VLANs, but hope you follow the demo. I hope this video helps. Okay, thanks for watching.